One of the most important concepts in math is that if you take one negative and you multiply it by another, notice the way I wrote it right here. You put the negative numbers in parentheses next to each other, and that means you're multiplying them. So here we have a negative 1 times another negative 1. And the idea is that when that happens, you get a positive 1. And what's interesting is you can think of them as pairs. Two negatives multiplied by each other give you a positive. So whenever you're given a list of negative ones or any negative number, what I usually do is think first of all, okay, how many negative signs are there? Well, here's 2, that's a positive, and there's another negative. Well, that'll revert it back to a negative, so this is negative 1. And that goes back to the rule that a negative 1 times a positive 1 is negative 1. So when you have two negatives, it's a positive. Then positive 1 times another negative 1, well, that's a positive times a negative, so it's negative 1. So any number of numbers that we have, like negative 2 times negative 5 times negative 2, well, there are three negatives here, so I know the answer is going to be a negative. The product is going to be negative. Negative 2 times negative 5 is positive 10, times another negative 2 is negative 20. So one of the underlying things that we're looking at throughout this whole video is the number of negative and positives. If there's an even number of negative products or numbers being divided, divisors and dividends, then the product or quotient will be positive. So that's one thing to think about as we're going through this. And one of the things I hope to get at a little bit is why does any negative number, like negative 1, times another negative number give you a positive 1? It seems that a negative multiplied a negative number of times would have to give you, a negative result. One way of looking at why it makes sense that this should be true is to think about division. And if I was encountered with the problem, okay, what should negative 2 times negative 5 equal? Well, a lot of people guess negative 10. But let's look at this from a different perspective. Here we're using multiplication. Let's use division over here and kind of think about it. 10 divided by 2 is 5. Okay. That also means that 5 times 2 is 10. These two statements are directly connected. In the first, I had 10. I divided it by 2 and I got 5. In the second statement, I just took 5 and multiplied it by 2 to get 10. The same is true here. If I took 10 and I divided it by 5, I would get 2, because 2 times 5 is 10. That's with positive numbers. What if I change it up a little bit? Well, if I had a positive 10 divided by a negative 2, what should I get? Well, I should get a negative 5. That's interesting. If I follow the pattern that I've been following this whole time, that would mean that, like here in the first example, 10 divided by 2 is 5, so then this number times 2 gives me 10. The same thing would have to happen here. We're not changing what division and multiplication are. If we did, then we would change their relationship. So here, negative 5 multiplied by negative 2 has to give me 10. Just like 5 times 2 here gave me 10, negative 5 times negative 2 has to give me this number right here. We don't want to make this equal to negative 10 because then this statement would be no longer true. We would be unraveling the relationship between multiplication and division. So this has to be a positive 10. If it was anything else, then multiplication and division would not be inverse operations, and that would be a big problem. Let's look at one more other example. If I took negative 3 and multiplied it by negative 4, I would get positive 12. And going back to the same idea here, I can quickly say that 12 divided by 3 is 4, since 4 times 3 is 12. So if I took a 12 and I divided it by negative 3 instead, we know we should get negative 4. So that means that negative 4 times negative 3, or in this case, negative 3 times negative 4, remember the commutative property tells me that the order does not matter, it won't change the product, has to be a positive 12. If it was anything but positive 12, then multiplication and division wouldn't be related as we know them. And that would be weird. I mean, 12 divided by 3 is 4, so then 4 times 3 would be negative 12. I mean, if we weren't getting back to this original number each time, we had to change all these rules. And we can do that. There's no problem with that. We can change our number system and our laws that relate to operations and numbers, but that's not our goal here. Our goal is to explore the number system as we've been given it and as it's been defined. So the same thing happens with negative numbers. If you take a negative 1 and you divide it by a negative 1, you got to get a positive 1. And this might seem odd at first with the 12, like, for example, divided by negative 12 divided by negative 4. How could that be positive 3? How could positive 3 relate these two numbers? And again, let's go back to our inverse operation idea. If I took 4 and I multiplied it by 3, I'd get 12. Okay, what does that mean? Well, that means if I took 12 and I divided it by 3, I would get 4. And if I took 12 divided by 4, I would get 3. So multiply these numbers and then divide the product by either factor and get back to one or the other. That's what we're doing here. So if I took 3, let's say negative 3, and multiplied it by 4, I would get negative 12. So that means that negative 12 divided by positive 4 would give me negative 3. And that makes sense. Multiplication and division are inverse operations, they're related. Well, what about if I had 3 times negative 4? That needs to be a negative 12. Well then, we would have followed the same logic in our most basic example and take negative 12 and divide it by negative 4. What should we get? Well, when we did 12 divided by 4, we got 3. So the same thing should be true here. We take 12 and we divide it by 4, negative 12 and negative 4, we should get the other number, which is 3. So in fact, this has to be a positive 3. If it was anything else, multiplication and division wouldn't be related as we see them here. These simple facts that we use and learn very early on in math would no longer make any sense. So what I'm saying here is that multiplication and division are related in this simple example, the way we see them. They have to be related in complicated examples as well. We're not changing those relationships. That's why math is all about patterns. Once you've established this pattern here, about how these three numbers are related, it has to also work in a similar problem, even if you're dealing with negative numbers. And that leads us to one other important thing. If we had negative 1, well, let's take negative 4, divided by 2. And remember that if you see a fraction, it's very important to be able to think about that as the same exact thing as this. Anytime you have a fraction, what you're really seeing is the operation of division. So this would be negative 4 divided by 2. These are the same statements. Well, what if we had 4 divided by negative 2, and then what if we wrote negative and then 4 over 2? Well, what do these things mean? Well, this one has to mean 4 divided by negative 2, and this one has to mean negative, and then the fraction. So let's put parentheses there, 4 divided by 2. So an interesting thing happens. These three have to be all equal, which is really great. In other words, you don't have to really worry about where the negative sign is in a fraction, is located in a fraction. If there's one negative sign in the numerator, denominator, or just in the middle, you have a negative number. Let's think about why this is true. A negative 4 divided by 2, which is what we see right here, is, well, negative 2. So let's see if we get negative 2 each time, which would mean they're equal. In our second case, 4 divided by negative 2, well, that's also negative 2. So far, okay. In our third case, remember the parentheses is established because we have one negative sign sitting out in the middle, which kind of means that we have 4 divided by 2, and then we apply the negative sign. So it would be like this. So 4 divided by 2 is 2. That's in our parentheses. And we have negative 2. What does that mean? Well, that's like a secret way of writing negative 2, because what it's meaning is negative 1, which is not written here, but it's implied. times 2, which is negative 2. So in all three cases, we get the same number. So please recognize that if the negative sign is in the numerator, the denominator, or the middle, it all means the same thing. You shouldn't worry about the location of the negative sign.